We are trying to find the domain and the range of this particular function called w of x. And so just to recap what the domain and range is, we have an input value, which is our x, right? So as you can see, we've got w and the input is the x. We put a number in there like 3. And that comes to an output, which is our y-axis. So how are you going to remember what these values are? So think of yourself as a queen or a king, and you look across your dominion, right? That's your land. It's horizontal, and that is your domain. Then think of yourself of the word mountain range, right? So mountain range, and that is this guy here, up and down, the range. Okay, so we have to think about the domain, and there's two ways that we can break maths. The first way is if we divide by 0. So again, get your calculator out, divide by 4, I don't know, 0 like that. What do you get? It should be undefined or math error, right? We just don't know. So that can happen in this function, right? There's also another way that you can break maths, and that is if you have the square root of a negative number. Something like square root of -7. Punch that into your calculator. If you're using a class pad, you have to turn off complex. You have to go to real, because there is a whole branch of maths that deals with the square root of -1 being this thing that we call I, and it is called an imaginary number. So yeah, make sure you turn that off. Cool, so we're not really dealing with the square root of negative numbers here, we're only dealing with that divide by 0. So normally when you have the base function of this, where you have like, I don't know, something called f of x, and that is equal to just 1 divided by x, we can say that our domain would be something like this. It comes in a bit of a fancy format. We say x is an element of, that's that weird e thing, and r is all the real numbers you can ever think of, like 2.3, fractions, like 1,000,000 divided by 60, all that sort of stuff. And we say that x cannot equal to 0. But in this guy, we've kind of shuffled it around a bit, right? Like we've got all of this stuff here. So what we say is we're going to solve for x. All right, we'll solve for x, and when that's equal to 0, and so that becomes this one, and then we divide both sides by 9. And there we go. That's as simple as it gets. So if we were to rewrite this equation here, for not for f of x, but for our equation, we would say that it would be this 4 divided by 9. Now, what's really interesting here is that all of this stuff, really, all of this stuff here, apologies, is moving the function left, right, and either like squeezing it in or making it like really shallow like that. So it's either moving it around like this. Okay? The only thing that affects the range is this +8. Because if we go back to our basic equation, this one here, we had f of x, and that was equal to 1 divided by x. We have +2. Well, what happens? What happens is we get something that looks like this, and it's kind of been moved up by +2, so it goes kind of up like here and down like that. So our range can't be this value of 2 anymore. So for our case, we've got a +8. So it's super easy for this one. We can just say that our range can't equal to 8. So again, we put the fancy format to say y is an element of all real numbers, and we say y cannot equal to 8. There we go.